You probably know how old the universe is. You've heard the number. 13.8 billion years. You've seen it in textbooks and documentaries, on the walls of science museums. The universe began with a Big Bang approximately 13.8 billion years ago. That's the age. That's the answer. Simple. Settled. Done. Except it isn't. That number, 13.8 billion years, is correct in one very specific sense. But the way almost everyone understands it is wrong in a way that reveals something so strange about the nature of light and time and space that once you actually see it, the night sky is never going to look the same to you again. Here is the question nobody asked when they hear that number. 13.8 billion years as measured by whom? From where? In what reference frame? Because here is what you need to understand before anything else makes sense. Time is not universal. It does not tick at the same rate everywhere in the universe. Einstein showed us this. Moving clocks run slow. Clocks in stronger gravitational fields run slow. Two clocks that start together and then separate, one traveling fast and one sitting still, will disagree about how much time has passed when they meet again. This is not theoretical. This is measured. GPS satellites run fast compared to clocks on Earth's surface because they are higher in the gravitational field, and the GPS system has to correct for this every single day, or your navigation would drift by kilometers. Time is relative. Always has been. Always will be. So when cosmologists say the universe is 13.8 billion years old, they mean something very specific. They mean that if you follow the expansion of the universe backward to the moment when everything was compressed into an unimaginably hot, dense point, the amount of time that has elapsed since that moment, measured by a hypothetical clock moving with the average expansion of the universe itself, is approximately 13.8 billion years. This is called cosmic time. It is a very carefully defined and very useful concept. But it is not the only way to measure the age of the universe, and it is certainly not the most mind-bending one. Now look up at the night sky. Pick any star you can see. The light entering your eyes right now left that star years ago, decades ago, centuries ago, millennia ago. You are not seeing the star as it is. You are seeing the star as it was, at the moment that particular light left it, which might have been before humans existed, before life existed on Earth, before the Earth existed at all. The night sky is not a picture of the universe as it is now. It is a collection of images from different points in the past, layered on top of each other, each one showing you a different era of cosmic history simultaneously. When you look up, you are looking back in time. And this is not a metaphor. This is the literal physical reality of what your eyes are receiving. Light travels at a finite speed, 300,000 kilometers per second, which sounds fast, but the universe is incomprehensibly large. The nearest star to our sun, Proxima Centauri, is 4.2 light years away. The light you see from it left 4.2 years ago. The Andromeda Galaxy, the nearest large galaxy to our own, is 2.5 million light years away. The light reaching your eyes from Andromeda right now left 2.5 million years ago when our ancestors were stone-tool using hominids who had never seen a written word. You are looking at 2.5 million year old light with your naked eye on any clear night. The most distant objects we can observe with our best telescopes are so far away that the light reaching us left them when the universe was only a few hundred million years old. We are seeing the universe in its infancy, not because we have a time machine, but because the light from that era is only now arriving here after traveling for billions of years. Every time astronomers build a more powerful telescope, they see further into space, and therefore further back in time. The James Webb Space Telescope is showing us galaxies as they were more than 13 billion years ago within the first few hundred million years after the Big Bang. We are watching the universe's own childhood delivered to us right now by ancient light that has been traveling longer than Earth has existed. But here is where it gets genuinely strange, and where the age of the universe becomes something much more complicated than a single number. When cosmologists say the observable universe is about 93 billion light years across, you might be confused. If the universe is only 13.8 billion years old, how can it be 93 billion light years across? Surely light can only have traveled 13.8 billion light years in that time. This is exactly the right question to ask, and the answer reveals something profound about the nature of space itself. Space is expanding, not just the matter in it. Space itself. The galaxies are not flying through space away from each other, the way fragments of a bomb fly through air after an explosion. Space is growing between them. New space is being created everywhere, all the time, pushing everything apart. And here is the crucial point. There is no speed limit on the expansion of space itself. Einstein's rule that nothing can travel faster than light applies to things moving through space. It does not apply to the expansion of space itself. Space can expand faster than light. And in the early universe, it did dramatically in a period called inflation. In the first tiny fraction of a second after the Big Bang, the universe expanded by an incomprehensible factor, growing from something smaller than an atom to something the size of a grapefruit. In a time so short it makes your head spin, expanding far faster than light could travel. This means that right now, today, there are regions of the universe so far from us that the space between us and them is expanding faster than the speed of light. Light from those regions will never reach us. The universe is full of things we will never see, not because of any limitation of our telescopes, but because the expansion of space is carrying them away from us faster than their light can cross the growing gap. The observable universe, the region from which light has had time to reach us since the Big Bang, is a bubble with us at the center, but it is not the whole universe. The whole universe is almost certainly much, much larger. Some cosmologists believe it is infinite, and everything beyond our observable bubble is, in the most literal sense, permanently hidden from us. Now think about what this means for the age of the universe. The light from the most distant things we can observe, the cosmic microwave background radiation, the afterglow of the Big Bang itself, comes from a region that is now about 46 billion light years away. But when that light was emitted, that region was only about 42 million light years away from where we are now. In the 13.8 billion years since that light was emitted, the space between us and the source has grown from 42 million light years to 46 billion light years. The source moved not because it was flying through space, but because space itself stretched, and the light spent all that time crossing that stretching space, arriving here now, carrying information about the state of the universe 13.8 billion years ago. So the universe you are observing is not 13.8 billion years old in any simple sense. The light you receive from different objects is different ages. The microwave background is 13.8 billion years old. The light from a nearby star is a few years old. The light from Andromeda is 2.5 million years old. You are simultaneously receiving information from thousands of different eras of cosmic history. The universe you observe is not a snapshot of one moment. It is a layered archive of billions of years of history all arriving at your eyes at the same time from different distances, showing you different epochs of cosmic evolution simultaneously. And here is the deepest implication of all of this. When astronomers say they observe a galaxy at a redshift of 10, meaning a galaxy whose light has been stretched to 10 times its original wavelength by the expansion of space during the journey, they are seeing that galaxy as it was when the universe was only about 500 million years old. That galaxy today, right now, is almost certainly completely different. It has had 13.3 billion years to evolve since the light we are seeing left it. It may have merged with other galaxies. Its stars may have lived and died multiple times. It may look nothing like what we see. We are not seeing a galaxy. We are seeing the memory of a galaxy, a fossil image preserved in ancient light, showing us what that region of the universe looked like over 13 billion years ago. The galaxy itself, as it exists right now, is completely unknowable to us. We will never be able to observe it in its current state because a light showing its current state will not arrive for billions of years, and by then our sun will be long dead. The universe is older than you think, not just because the number is larger than people appreciate, but because the nature of what it means to observe the universe across cosmic distances makes the very concept of age far more complex than any single number can capture. The age you have been given, 13.8 billion years, is a carefully chosen reference point, useful and precise and correct in the way cosmologists intend it. But the universe as you actually observe it is a palimpsest, a document written over and over again on top of itself, each layer a different age, each star a different era, each galaxy a different chapter of a story that began 13.8 billion years ago and is still being written in every direction at this moment. The next time you look at the night sky, you are not seeing the universe. You are reading its history. Every point of light is a message from the past, traveling at the only speed nature allows, carrying information about a moment that is already gone by the time it reaches your eye. The universe you can see is a museum. The universe as it actually is right now is beyond your reach, hidden behind a wall of expanding space and the finite speed of light, unknowable in its present form. That is not a limitation of science. That is the structure of reality itself. If you want to keep seeing the world for what it actually is, not what it appears to be, subscribe. That is what this channel is for.